Hello students, how are you? Hope you are doing well. Now I am reading the question. A galvanometer of resistance G ohms is converted into an ammeter of range 0 to I ampere. If the current through the galvanometer is 0.1% of I ampere, the resistance of the ammeter is option A G upon 999 ohms, option B G upon 1000 ohms, option C G upon 1001 ohms, and option D G upon 100.1 ohms. So the problem is based on the particular instrument which is known as the ammeter. Now to make the ammeter we use a galvanometer. Earlier the galvanometers were used to measure the current, but the problem with galvanometers is that they carry a very small amount of current. They are able to carry a very small amount of current. Suppose if you want to pass a large amount of current through them, their wire may damage, and to make them safe we place a shunt. It means that if we want to improve the range of the galvanometer to make it as an ammeter, we have to use a shunt in parallel with the galvanometer. So we can say that a galvanometer in parallel with a shunt resistor, this combined, or we can say that this combination is known as ammeter, having a large range as compared to the galvanometer alone. So in this particular case, we have to design an ammeter of range 0 to I ampere. It means that the total current that can pass through this particular arrangement of an ammeter, this ammeter is 0 to I ampere. This is the maximum range I ampere. Now in this particular problem, it is said that if the current through the galvanometer is 0.1% of I ampere. Now what is 0.1%? 0.1% of I. 0.1% of I means 0.1 divided by 100 times I, which is equal to I upon 1000. So this is the maximum amount of the current that can pass through this galvanometer. This particular current, which is I upon 1000 amperes, it can pass through the galvanometer. If the current goes above this, the galvanometer will damage. There will be a damage. This data is provided in this particular problem. Now we have to find out the resistance of ammeter. Resistance of ammeter. Resistance of ammeter means the resistance of this whole arrangement. The resistance of this whole arrangement. Whole arrangement means the parallel combination of G and S. So we have to find out the parallel of G and S. But to calculate it, we have to find out the value of S. By finding the value of S in terms of G, because G is the resistive value of galvanometer, G is the value of the resistance of galvanometer. So we have to find out the value of S, that is shunt, in terms of G, and then calculate the parallel combination to find out the overall resistance of the ammeter. So there is a basic concept here which is used, that in parallel voltage is same. It means that we know this current I upon 1000 that is passing through this galvanometer. The maximum current is passing here is I. It means that the remaining part, I minus I upon 1000, which is equal to 999 upon 1000 I, this will pass through this particular S. So this is the value of current. Suppose it is I dash. So I dash is 999 upon 1000 I. This is the value of current which is passing through S. Now in parallel we know that voltages are same. It means that this current I upon 1000 multiplied to the resistance of this is equal to I dash, the current flowing through S, multiplied by the resistance of S, that is shunt. So in this way we have equated the voltages across these two parallel elements. So we can say that I upon 1000 multiplied by G is equal to I dash multiplied by S, where S is the value of resistance of the shunt and I dash is the current flowing through this particular shunt, which we have calculated as 999 upon 1000 I. So in this way, this is I upon 1000 times G is equal to I dash. I dash is 999 upon 1000 I multiplied by S. Now this I cancels with this I, this 1000 cancels with this 1000. So the value of S comes out to be G upon 999. By cross multiplying this 999, the left hand side. So this is the value of S, which is the shunt resistance. Now, as I said earlier, resistance, the resistance of ammeter, the resistance of ammeter is the parallel combination of G and S. Is the parallel combination of G and S. That is the resistance of galvanometer and the resistance of S. The resistance of galvanometer is G and the resistance of shunt is G upon 999. And we know that if there are parallel combination of two resistance, suppose one resistance is R1 and the second one is R2, then the parallel combination R equivalent is R1 R2 upon R1 plus R2. We use this rule, apply this rule, G multiplied by G 999 divided by G plus G upon 999. After solving this comes out to be G square upon 999 divided by, taking the LCM as 999. So this we get as 999 plus 1, which is equal to 1000, and this cancels with this, and we get the final result as, and here 1 G also, this G cancels with this 1 power, and the final answer is G upon 1000. So G upon 1000 is the value of the overall resistance of the ammeter. So option number B is correct here. So hope you understand this problem. Thank you.